Hello, Math 30-1s. This is the last lesson in trig identities. This one is about solving equations with identities. What we will do is always keep our formula sheet beside us. We're going to utilize these identities when we're solving an equation. Let's take a peek at one. Let's solve the following equation and write a general solution in degrees. Okay. The first question I have to ask myself is, when do I need to use an identity? Well, I'm going to use an identity here because one of my angles is a double angle and one is a single angle. So that's an immediate hint that I want to use an identity. I also want to use identities when I've got, say, cosquareds and a sine, like that. I can't solve it. It's two different functions. So we're always looking to see if we can make our functions look the same. Okay, so let's do that. So I see this double angle and I say, okay, I don't know how to solve angles that are double. Well, let's get rid of it. Let's go look. Sine 2 theta. Hey, that's on my formula sheet. Sine 2 alpha is how they write it. Well, no big deal. It's the same idea. Let's go back. So sine 2 theta is 2 sine theta cos theta is equal to sine theta. Now, a number one mistake that I'm going to see here, especially because we've been doing identities, is I'll see students do this. They'll say, oh, sine theta on both sides. Let's divide. And they'll go whoop, 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 and they'll do that. No bueno. You never do that when you're solving an equation. We just lost functions. You're allowed to divide when you're solving or proving an identity, but we never divide out functions when we're solving an equation. So let's try this again. Well, if I can't divide out functions, well, maybe I bring everything to one side. Perfect. Now I say to myself, oh, look at it. We can factor that thing. I like to use brackets there just to make it more clear. Okay, we're factored, so we can use the zero product property. So therefore, sine theta is equal to 0, or 2 cos squared theta minus 1 is equal to 0. Might as well simplify that down to there. Okay, and so now, perfect. I know I'm doing this right because I'm seeing things that I can find on my unit circle. So this one said we're going to find the general solution in degrees. So when I find my general solution, what I like to do is find my answer for 0 to 360 first. So where is sine 0? Well, that's at 0, 180, 360. Where is cosine a half? Well, cosine is a half at 60 degrees, and cosine is a half in quadrant 4 then at 300 degrees. All right, so if I was asked to find my solutions from 0 to 360, here's what it would look like. But I was asked to find the general solution. So the general solution, what I like to do is I like to draw a picture. And here's my picture. Not a good artist. What I'm going to do is I'm simply just going to go and label or draw my terminal arms here. Well, here's 0, 60, 180, 300, and back to 360. Okay, what you're looking for here is you're looking for a pattern between the distances, angular distances, in our solutions. So pause for a second, see if you can see any patterns so we can combine some of these solutions together. You may be able to combine all of them, maybe you can't. So take a second, see if you can find a pattern. Okay, let's see if you found one of the patterns. One of the patterns. Okay, what does he mean? Well, what I noticed is this. I'm going to say, let's change pen to pink. Do you notice 60 to 180? That's 120 degrees. 180 to 300, that's 120 degrees. 300 to 60, that's 120 degrees. Oh, I see a general solution right there. So one general solution could be this. 60 degrees plus some multiple of 120. Then I'm going to look at this. I skipped it. Well, let's make a general solution for this then. 0 degrees plus it would take me 360 or some revolution of it to get back to where I began. And of course, n is a member of the integers. Okay, there's one general solution. It's not the only general solution. Maybe some of you saw this instead. Maybe I'm going to switch to what's a pretty color here we haven't used, light blue. Maybe some of you said, listen, I'm just going to look at that as a pair. Okay, so if I saw that as a pair, I could say I noticed the distance between my blue terminal arms there is 180 degrees. So again, I like to write that 0 in. So starting at 0, I'm going to do a distance of 180. Well, what about my other two terminal arms if I'm looking at it this way? Well, here's 60 and here's 300. Well, there's no distance pattern-wise that those two angles are traveling to get back to each other. So all I would do here is I could do this. 60 plus 360 and 300 plus 360 and a member of the integers, and there it is. So, I mean, it's easy for me to demonstrate on my tablet because I've got all these different colors. But honestly, if I was writing this as a test, I do bring I usually bring pencil crayons with me, and I color it. So I color code it. It makes it really easy for me to see. That's it, friends. So I'm going to come back up, and I'm going to look at this question one more time. Why did I have to use an identity here? Because I recognized I had a double angle and a single angle. I can't solve it. I'm going to have to use an identity whenever I start having to solve things that are in different functions. Here I would look for an identity. If I was given cos squared is equal to sine squared, I would go and look right to my formula sheet and say, wait a minute, cos squared is 1 minus sine squared. And now I'm all in terms of sine. Now I can solve. Okay, now that we solved that question algebraically, let's think about how we could verify our work graphically. Well, all I'm going to do is make sure I'm in degree mode. I am. And I'm going to just graph the original, not what I came up with. Because if I made a mistake in switching using an identity, I don't want to get it wrong. So all I'm going to do is simply just graph this. Let's check my window settings. Yeah, I'm going to switch this again. I wish the TI did this. I don't know why it goes to those strange values. Okay, and there we go. Let's just zoom in a little more here. That should do it. Hit graph. There's the first one. There's sine theta. And so now if I want to check my answers, well, again, all I'm going to do is find my points of intersection. And so there's the first one. It's at 0, 0, just like we said it would be, right? I'm just going to scroll up closer to this one and enter, enter, enter. Hey, there's the next one right where we said it would be. It would be at 60. Now, if I'm on a test, or absolutely if I'm on my diploma, I'm not just going to say, okay, that's good enough. I'm going to go find probably all of them from 0 to 360, just in case I screwed up. But hey, 180, at this point, I'm pretty sure we've done this thing right. So what I want you doing on questions with identities, any equation for that matter, I want you to do the question algebraically, check my work by graphing my answers. Why not? There it is, friends. There is solving equations with identities, and you are almost done, trig, finally.